and he can go ahead and get started.
Thank you so much, Megan. I'm really excited to be here. It's interesting to talk to a screen and not be able to see all you guys in person. It'd be really cool to do that, but this will be a great alternative for now. So today I want to talk to you a little bit about MemSQL. Basically, the goal of this talk is to invite you in joining us in our vision of building a data platform. My name is Carl Sever. I'm a director of engineering. I run a team called the platform team at MemSQL. The platform team is really responsible for building the ecosystem around the database engine and enable all of our customers to achieve like the maximum value they can out of the product. So that's sort of the goal of the platform team. And I'll talk a little bit more about the engineering organization later on, so you get an idea of the way in which we organize the teams and sort of work together to be able to do what we're trying to do. So to get started, that's not going. Okay, cool. So just to get started, we'll do a quick summary of the talk today. I'll do a company overview, talk a little bit about where we came from, what our original goal was, how it's iterated. We'll talk a little about what MemSQL is, like what is a database sort of thing, just high level. I assume some of you guys are familiar with databases. Some of you may not be, so I just want to make sure we're all on the same page. I'll be talking about the engineering organization at MemSQL. I'll be talking about the actual position that I'm really interested in, hopefully having all of you apply to by the end of this talk. We call this position the software engineer web role, and then we'll have some time at the end for questions. So that's the plan. So without any more time, let's get right onto it. So company overview, in sort of three big numbers, we were founded in 2011. Our founders are from Facebook and Microsoft. All of our founders have background in databases, data science, data processing, basically data star. They have like a really solid background and have set us up to succeed from day one. We were part of Y Combinator Winter 2011's class, and that has really set us, that gave us like initial contacts and set us up for a great like many years in things. So I guess it's been 7 years or 8 years. It's 2019, I always forget about that. Cool, so that's like the background of where we came from. Today we're at 140 employees. We have offices in San Francisco and Seattle. We have remote employees elsewhere in the USA and Europe. So we are a distributed database company, and so we have a distributed team. We basically want to hire the best people no matter where they are. And we have had over $100 million in funding. That's a huge accomplishment, I think, for any company. And even more awesome is that our investors include some of the best investors in Silicon Valley. We have Axel, we have Khosla, we have Google Ventures. They all believe in our mission, and they believe in us to achieve that. In addition, our board of directors has some industry veterans. So we have people who have actually gone through what we're doing before with other products, right? So we have people from the database ecosystem, we have people from storage and execution. We have a really solid team that's setting us up to succeed. So I think one thing I'm really excited about at MemSQL is that we have a history of innovation. We initially focused on providing a memory-optimized relational database. There's a lot of buzzwords there, but you could basically understand from our name that MemSQL, memory SQL, we are essentially a database company. We use the SQL query language, which I'll talk a little bit more about later. And we were initially memory optimized. The idea of being memory optimized was taking advantage of the advent in relatively inexpensive memory. Right? It became possible around 2011 to 2013 that you could actually have enough memory to be able to store a non-trivial amount of data without having any of it be actively from the disk. So all your queries are essentially processed at memory speed. This is a huge upside to certain types of workloads, which have to be as fast as possible. And so our initial offering was really focused on memory and how to take advantage of memory for a database. Over time, over the last 8 years, we've been focusing on responding to the market and continuing to innovate within the database ecosystem. Well, something we built really early on was a scale-out distributed system, which allows us to store more data and process it in more parallelism, which is a huge advantage for our customers. We also added a hybrid disk memory column store storage engine. So again, lots of buzzwords. The basic idea is we want to be able to use both disk and memory together to be able to store as much data as possible. Disk is a lot cheaper than memory, so for certain workloads you have to use disk. But we want to be able to use memory still to be able to accelerate those queries. So the goal is like a hybrid offering. And our column store was an industry first, which was really exciting. We also invest in cluster management tool chains. So we're one of the only database companies to really make a huge emphasis in simplicity of management. So we have like a one-click installer. We have tons of investment in how it's easy as possible to use MemSQL. And the advantage is the easier MemSQL is to use, the more time users spend working with their data instead of managing the system that manages their data. So we want to basically have people focus on the real value. And then something that might be really interesting to this particular group, because I understand you guys have a lot of experience with like full stack development and related technologies, is that we have a really innovative data management studio offering. So it's essentially a product that is shipped for free to all of our customers with our actual engine product. And it allows people to have sort of a single pane of glass perspective on a database cluster. So they can look at everything from health metrics, how is the cluster doing, how is it behaving, for example, they can run queries interactively in a UI. So that's sort of a newer investment that we've put in the last year, and it's taking off. People are really, really loving it, and we're investing heavily in that. So yeah, so moving on. What does MemSQL do? So I just spent like a whole slide talking about a bunch of buzzwords, and it's all like a little bit vague, but hopefully I can sort of nail down like why MemSQL exists, what value we provide, and the way in which our technology supports that view or value or goal. So yeah, what does MemSQL do? So I like to say that MemSQL is a data platform. We believe really strongly that every company should be able to use their data to generate value. That's just the core of it. If you go to our marketing website, you're going to see the same thing said in a million different ways. We believe that companies need to be able to use their data. We live in a really interesting time, right? So many companies are generating insane amounts of data these days. And it's one thing to generate it. It's relatively easy to generate data. It's a lot harder to actually make use of that data. So that's sort of our core value, our core goal. What is using data? Like, what does it mean to be able to like use your data to generate value? We sort of see it as broken out into sort of three main facets. The first facet is you need to be able to collect your data in real time. Basically, as the data is generated, you should be able to collect it and immediately start acting on it. There doesn't need to be a delay between collection and action. An example of that is Uber, right? So if you think about how Uber operates, they need to constantly know exactly the position of millions of cell phones, whether the cell phone is in a car, which is like operating as a driver, or the cell phone is in someone's pocket who's trying to pick up a ride. Knowing where all those cell phones are and being able to make decisions based on that is a really hard problem, and it requires being able to look at the data as it comes into the system. Another tenet of using data in a data platform is enabling easy and fast access. The best example of this, or a really good example of this, is something we've probably all felt, is sort of the pain of like swiping a credit card and having to wait for a transaction to go through. That's like a bad user experience. And ultimately, it comes down to the technology under the hood, being able to decide that this transaction is not fraudulent and that the transaction is valid, right? So MemSQL enables companies in financial space to be able to do things like real-time fraud detection, so that as the user swiping the credit card, as soon as we get that information, we can immediately make a decision about whether or not the transaction should be valid. That's an example of enabling easy and fast access. And it's key in any data platform or data-driven organization. Finally, the final tenet is storing it efficiently. Efficiently means two things here. One thing is we don't want to use up very much space to store the data, right? We want to keep the data relatively compressed. And the second thing, we want to store it in a way in which it's really efficient to actually query and like learn about that data. So an example of this is like a video game company. They might store terabytes or petabytes of user metrics. All that data needs to be compressed because otherwise it would just be too much data to sort of store in any single system. But it also needs to be available in a way that when you want to actually ask questions, it's efficient. So between those two things, you're looking at essentially, you need to be able to store it efficiently, right? So there's a storage component. So anyways, hopefully that gives you guys an idea of what a data platform is. And ultimately, a data platform needs a database. Every database on the market has a different set of trade-offs. I'm sure that through this, the projects that you guys are working on, you've been experienced or open to the idea of a database, and you've probably even heard about some of the databases in the market, or maybe even used them. Some examples of databases you might have heard of is like Cassandra, MySQL, Postgres, MongoDB, Redis. These are all databases. Every database has a different set of trade-offs. Sometimes you want more structure or less structure. You might want to use one query language or another query language. You might be something that only runs on one machine or many machines. Each of those trade-offs is optimized for particular types of use cases. For our use cases, basically being a data platform, which I talked about in the last slide, our use cases require that our database has the following properties. We're relational, so you can think of relational database as sort of like a really big version of Excel, if you're familiar with spreadsheeting software like Excel. All the data is organized into rows and columns, and all the columns have very explicit structures. So essentially, we know that a column has like a particular type, for example. Understanding that structure allows MemSQL to do very advanced optimizations that we wouldn't otherwise be able to do. So relational is a very key tenet of our requirements to be a data platform. Distributed is the second requirement because a single server can only do so much work, right? You can only have so many CPU cores in one machine. You can only have so much storage that's efficiently accessible by a single machine. So when you have that in mind, if you want a system to be able to scale to like arbitrary sizes, like terabytes or petabytes of data, you need to be able to scale out to many different machines. So a MemSQL cluster is essentially composed of many individual Linux servers, which allows us to scale out, giving us more storage and parallelism than a single server can do. That's the idea. And the third tenet, or the third trade-off that we decided to go with for MemSQL is that we are a SQL language. We use the SQL language. It's pretty obvious from our name that we are a SQL database. SQL essentially means structured query language. You can think of it as a programming language for asking questions about data. So pretty much any question about data can be represented in some form of a SQL query. SQL queries tend to be very declarative. So for example, a SQL query might ask, give me the sum of all the revenue of all the products that was sold last year, right? So the database needs to know which products were sold last year, that you're interested in the revenue, not anything else. And then that the database needs to be able to go and add all the revenues up into a single metric. So you can ask that question exactly in that way. Like what I just said is essentially a SQL query. So the user doesn't have to think about all the work to actually go into doing that. They just need to ask what they want. So those are the ideas of what it means to have a database, and it's like exactly what our database is. So moving on. That ties into engineering and MemSQL. MemSQL is an extremely strong engineering culture, and we also have a very strong engineering organization. We thought really hard about how to make our engineering organization maximize the ability for everyone to be strong, like have a strong impact. That's our really ultimate goal. We want to make sure that every time we hire someone, we're taking the maximum advantage of their ability, right? We want everyone to be able to work and deliver the most value possible. It's a win-win situation. MemSQL does better, but also everyone does individually better because they grow and they learn more and they're able to have a really awesome career at MemSQL. So our engineering organization is composed of many small teams who all work together. Everyone is expected to have a super high impact and take initiative. So we really value the type of personality where you don't just wait for something to happen. You go and do it. If you see an opportunity to generate value at MemSQL, do it. That's what we're looking for. We really, really value code quality, mentorship, and continuous education. We believe that everyone can learn something. No one has learned everything. And once you stop learning, you sort of become legacy or ancient. We want people to stay on the bleeding edge as they go. And to that extent, we make sure that everyone has good mentorship. Everyone is pursuing continuous education, whether it's taking some classes, doing some side projects, doing mentorship, helping out other people, whatever it is, we want to make sure it happens. And then the last thing that I think is a really strong value of MemSQL is code quality. I would even say that it's more like just building really, really robust software. We believe that as a startup, we need to sort of set the bar. So when our customers use our software, they don't see crashes or issues. They just see an amazing piece of software that does exactly what it's supposed to. So we really, really value code quality. And that's something that's like pretty key at MemSQL. Part of code quality is peer code review and tests. So everyone in the organization, no matter how senior they are or junior, we expect them to do code review, have code review happen to them. So essentially have other people review their code and write tests. So you'll see that across the board, and every single day we run millions and millions of tests in our testing platform. So it's a pretty core tenet of how we develop software. Another question I get a lot is sort of management and growth, so I thought I'd address it in this slide. The key things about MemSQL engineering is that it's a very flat organization. So we essentially have our VP of engineering, who sort of like runs the overall team, make sure that we have a really good budget, make sure that we are hiring and all that type of stuff. We have engineering managers. So I'm, for example, an engineering manager, and then we have individual contributors, and that's it. So if you look at a lot of engineering companies, you'll see many different types of sort of management overhead. Sometimes you'll see a lot of management overhead. Sometimes you'll see very little. I think that we are sort of on the very little side of things. So doing something inside the engineering organization requires relatively low amounts of oversight and like approvals, right? So we can basically make things happen really fast. And that's key. MemSQL wants to move fast. We want to build really awesome software. And so we don't want things to get too much in the way of that. So low management overhead. Another really interesting point is that all of the managers inside MemSQL engineering were previously principal engineers, either at MemSQL or another company. So essentially, everyone at MemSQL who's managing is a technical engineer, someone who's written tons and tons of code, has worked on exactly what they are managing, and knows a lot about the system. This allows us to ensure that every engineer doesn't have to explain really silly concepts to their manager, right? Most managers, or every engineer, or every manager knows what their engineers are working on and is able to do that work as well. So we have a really tight synergy between management and individual contributors because of that property. And something else we do is we have a really strong growth path. So we believe really strongly that everyone should grow. So we have company-wide performance reviews. So essentially, twice a year in the fall and the spring, we do performance reviews for everyone in the company. And in engineering, we rank everyone on sort of 4 main points. And these 4 main points are these ones, the growth metrics. So every engineer is expected to grow in technical, strategic, leadership, and communication categories. We have a pretty comprehensive engineering growth chart internally, which outlines exactly sort of the expectation in each of these categories for every level of engineering. So as you get promoted through the engineering program at MemSQL, you'll know exactly where you are, what the current expectation is, and then what the expectation is at the next level. And so you can continue to mentor and like take classes or education or just work harder towards the next level of your growth path. And that's pretty key. Everyone wants to know how they get promoted. Everyone wants to know when they're going to get promoted. It's actually pretty easy, and I've never promoted someone who didn't know they were going to get promoted. We make sure it's a very open process. It's not like a surprise. So that's the idea behind like how we organize and run the engineering team. So the obvious next question is, would you fit into MemSQL? What we're looking for are people who fit into these general categories. We want people with a growth mindset. We want people who are open, curious, determined, that they're quick to try new things, right? They go after things that need to happen. They generate value. We want people who want to work in high-impact, fast-moving teams. It's not going to be necessarily easy to work at MemSQL. We want people who like challenge, like hard stuff, but I can guarantee that MemSQL will be a very rewarding place to work and will set you up for success in the long term. We want people who sort of see themselves as shipping faster, like shipping more code faster and with higher quality than most of their peers. We want really, really good engineers, and we want people who know they are. That's a really key part. We also want people who sort of see failure as an opportunity to learn, right? Failure is not the end. Failure is the beginning. It's like how you know you need to change something. We don't want to fail, but we definitely want to learn when we fail. And when we fail, we want to sort of make some huge progress because of it. So that's the idea of failure in MemSQL. It's not the end of the world. It's just part of the process. And then the last thing, I think every company asks for this, communication skills and teamwork is actually a key part of any successful company. If your people can't work together, they are just like not fun people to work with, that they have bad communication skills, they're just not going to do as well as someone who has good teamwork, good communication skills. People actually like working with them. So we really value this highly. We want a really, really strong culture. We want like an engineering leadership culture, like people who are just amazing engineers. We don't want to give up having a fun culture. We don't want to give up having people who really enjoy working on MemSQL and working with their peers. So those are really important parts of what it takes to work at MemSQL. So hopefully all of you fit into these categories, because I'd love to chat with every single one of you. So the position that I'd like to outline today is called the software engineer web position. Basically, this position is a position that will work. It is an engineering position, but it will work really closely with our marketing team. We already have one engineer in this position who has grown a ton since he started, and we're excited to sort of grow the team and start trying out more initiatives beyond just what we've done so far. This person is expected to work on extremely high impact projects. Every project that the software engineer web position works on is directly aligned with our revenue generating value chain, right? So if we do better at our corporate website, our blog, docs, forums, landing pages, whatever it is, we do better in those categories, we're gonna generate more money because we're gonna generate more opportunities, right? So it's all about growth. It's all about making the company do better. And you'll be part of exactly that value chain in the company. Some examples of some projects that have been done recently by the other engineer in this position that might be interested to all of you, just to get an idea of what you might be working on. So there's obviously the sort of basic stuff like writing landing pages and so on, but there's also some pretty interesting things. Like, for example, we completely rebuilt the corporate website. We moved from a very legacy architecture, which was like a Flask Python server with statically generated HTML and CSS, like just very old school. We moved from that into a new Gatsby.js-based architecture. So if you're familiar with Gatsby, or if you aren't familiar with Gatsby, Gatsby is essentially a static site generator that uses React server-side rendering to build like a statically generated website that then runs as a JavaScript app in the browser. So you get sort of the best of both worlds, and it's a really awesome framework to work within. So we moved the entire core website from legacy architecture to Gatsby. And that was done by the single software engineer web engineer while he worked on a bunch of other stuff. So it was an absolutely epic process, and I just remember it was just so cool. So that's like a great example of the types of things you might work on. It's not just writing HTML and CSS landing pages, it's actually working on hard architectural problems and making big changes in the org. Some ideas of things we might work on soon that we're really excited about is we want to migrate the blog into Gatsby, which is a pretty interesting process. We're migrating landing page CMS into Gatsby, so we're essentially building like a static site generated landing page CMS for our marketing team, which is a little bit complicated sounding, but it's a really cool project. What else are we doing? We're doing a bunch of really cool things. Like, for example, in our documentation, we're massively overhauling our docs to make it easier for people to learn. But that includes writing like sort of semi-interactive tutorials. So there's a lot of interesting like JavaScript projects within that field. So hopefully it gives you a little bit of idea of what you might work on at this position. So in addition to that, something else I get a lot of questions about is like, what are the growth opportunities? Like, where can I go from software engineering web? Basically, I look at it this way. You can go wherever you want. MemSQL is very much if you deliver value and you demonstrate sort of some type of skill, then you can do that skill and you can deliver that value. So some examples of where you could grow from this position include our software engineer applications position. So essentially working on our core applications like the data management studio interface that I mentioned earlier. We also have product management openings all the time, which is an absolutely cool position where you get to work on actually thinking about how are we going to ship this product, talking to customers, helping them understand why MemSQL is what they need, and getting an idea of what they need for them to be able to use MemSQL. And then another idea might be like sales engineering. If you're interested in seeing that synergy between engineering and sales, we have a really strong sales engineering team that goes right into customer environments and deploys MemSQL in crazy ways. There's a lot of sort of custom development in those situations. That is always a fun thing to work on. So just some examples. We absolutely support growth. Everyone in the organization is constantly growing and changing and shifting, and we recognize that your priorities change over time. But we do believe the software engineering web is an amazing place to start at MemSQL. Finally, we have a sort of set of requirements. I think that what I'm most interested in is people who demonstrate value just from day one, from when I first chat with them. If you are already demonstrating value, then you're a great candidate for MemSQL. Some things we look for projects on GitHub, CodePen, personal site. I definitely want to hear about what projects you guys will be working on at Lambda School. Any type of project that you have in your resume is key to help me understand what you've worked on, why you worked on it, and what you're passionate about. We want people who've experienced moving from designs, just like images, into actual working applications. So that's a key part of this position, is that you'll be doing a lot of work with our design team. And as part of that, you'll need to be able to move quickly from sort of design into code. Just for anyone who's interested, our design stack includes Figma, which is like a multi-user version of Illustrator, essentially. So it's like a networked version of Illustrator. It's a really cool software to work with, and it makes translating from design to code really easy. Like a lot of the questions you might ask the design team just answered automatically by Figma. So there's some really cool stuff there. Another thing we really care about is we want people with actual experience writing websites, right? Public-facing websites. I'm totally okay to look at your experience on in Lambda School and stuff like that as valid experience. We want people who've worked with the browser. Browser is sort of an annoying thing to work with. It has annoyances related to not supporting all the JavaScript features or HTML and CSS features. It has annoyances related to offline versus online, stuff like that. So we want people who are willing to work within those requirements and those restrictions and still build a world-class application. So that's what we're looking for. We absolutely need to have people with advanced knowledge of modern HTML and CSS. Our software looks and feels amazing because the code is awesome. So we need people who have a good basis in those two components. We also need people who have experience with JavaScript, although we're willing to mentor people into sort of advanced JavaScript experience. So we more need people to get up and running in modern HTML and CSS background. So lots of talking. I hope I didn't go over time, but that's the basic idea, and I want to open up for as many questions as possible, just in case anyone wants me to focus on a particular area, rather than me assuming what areas you're most interested in. So yeah, thank you so much, and absolutely let me know which questions you have.
Great. All right. Let me go ahead and pull up the questions here. You did a great job with the presentation. Very thorough. It's perfect. One student asked, if we want to tinker with MemSQL, what repo do you suggest we check out on your GitHub?
Awesome question. So there's sort of two ways I recommend playing with GitHub. And I'll actually have, when Megan sends out sort of some information after this, I'll have them include some getting started information, so it's really easy. The first way that I recommend taking a look is we have a Docker image that we publish, which basically we call it MemSQL cluster in a box. So the idea is you have one Docker container, which runs two MemSQL nodes, which are clustered together. And it's a really fast way just to play with MemSQL on your laptop. So assuming you have Docker running on your laptop, you should be able to get started with cluster in a box really easily. And if you go to our main MemSQL docs page, you just go to installing MemSQL, you go to one machine cluster in a box or Docker, you should be able to find it there, but I'll link you guys directly to that. So that's one way that you can get started really quickly. Another way to get started with MemSQL is using our more advanced installation guide. So if you want to actually install MemSQL directly on different machines and sort of see how that works, there is sort of a comprehensive install guide that allows you to deploy many different virtual machines. Let's say you had 3 VMs on Amazon, AWS, you could run MemSQL across those 3 machines. So those 2 ways are really good ways to start with MemSQL. I hope that answers your question.
Great. What technologies are used in the main application?
Cool. So we have, as I said, we have a number of main applications. So I'll just sort of briefly give you an overview of technologies ranked from most commonly used to least commonly used. So the most commonly used technology, language at MemSQL is C++. So the actual database engine is written in C++. It's millions of lines of C++. It's absolutely massive. That's the biggest sort of single piece of code that we have. In addition to C++, we have tons and tons of Python because all of our tests are written in Python. So we have just an obscene number of tests, and they're all written in Python. So those 2 languages probably are the majority of the languages at the company. But in terms of what the customer interacts with, they actually interact with a lot of other technology that's written in neither of those 2 languages. So our core tool chain is written in Go. So basically all the technology that manages a MemSQL cluster, deploys MemSQL upgrades, stuff like that. That's all written in Go. We have Python inside our like web services, so there is some more Python there, just running some basic web services, stuff like that. Our front ends are all written in either Flow or TypeScript, so we basically always want to have like a type system supporting our technology. So we primarily will use Flow or TypeScript whenever we're writing JavaScript. In terms of like sort of stacks in the front end side of things, our core application, MemSQL Studio, is written using React, Redux, TypeScript. What else? We use a lot of sort of more modern technologies inside the browser. For example, we use WebSockets and web workers extensively. So that's sort of an interesting thing. Yeah, so Studio is mostly those technologies. Our core website technologies are Gatsby.js, as I said. We use Redux there as well. A lot of it is just statically rendered, so it's pretty simple. And then our customer portal technology is basically Flow, although we'll be transitioning to TypeScript soon. And it is Apollo with GraphQL, and then it also has Redux. So that's sort of the idea of the tech stack. What else did I miss? Go JavaScript. I think that should give you a pretty good summary of like most technology that we use.
Great. Does the role involve interacting with the MemSQL code base directly, or is it more peripheral?
So the software engineer web role is primarily at interacting with sort of the marketing team, those projects that I said, like memsql.com, web, and stuff like that. And the closest thing you'll probably get to working with like the MemSQL code base would be working on the customer portal. Customer portal is internally called Freya, which is our code name for our sort of like build deployment system. It also allows customers to get their own licenses. It's a pretty cool system, and I would say that's probably the lowest level code that we're looking at for this particular role. As I said before, we support growth at MemSQL, so where you start at MemSQL doesn't preclude you from working on any other area of the company, including the database engine.
Great. And then last question, we're a little short on time here, but have you observed SSDs becoming a bigger presence in data warehousing?
So question, can you repeat it again? Sorry, someone was yelling outside.
You're fine. Have you observed SSDs becoming a bigger presence in data warehousing?
Yeah, absolutely, yeah. So the advent of SSDs is just huge. And even more than SSDs, we've also seen a huge growth in like NVMe usage. And then Intel now has like some really, really interesting like RAM level drives. So essentially like non-volatile RAM, but something that preserves its state even when it's powered off, which is a really interesting technology. We're seeing all of that completely blow up around the world, which is really interesting. Our column store takes advantage of SSD performance in a really nice way. We also work really, really well on NVMEs, but we can also work on magnetic disk drives, like older school drives. So in summary, yes, we're seeing a huge explosion in usage of SSDs and even more sort of esoteric storage solutions. But we're also seeing, we're basically also like able to sort of support all of those different technologies within our data storage system. So hopefully that should answer your question.
Great. Well, we're going to go ahead and wrap things up because we are out of time. But thank you so much. That was a great presentation. Very, very cool company. And I know we're going to have a lot of students that are interested. So I will follow up with you after, Carl, and we'll get next steps in place. Students, thank you so much for taking the time to join us today. And I will let you all know next steps when we get those nailed down.
Sweet. Yeah, thank you so much, Megan. And it was really nice being able to talk to everyone. I really hope I'll be able to meet a lot of you at some point soon.
Great. Thank you, everyone. Thanks.